Now in this tutorial session we are going to see third problem. In the third problem we'll see series RLC AC circuit. Okay, the question is a 230 volt 50 hertz AC supply is applied to a coil of 0.06 Henry inductance and 2.5 ohm resistance connected in series with a 6.8 microfarad capacitor. Okay, so by using this data we have to draw the exact circuit diagram. Okay, so for the solution, resistance and inductance, capacitor, these three elements are connected in series and the resistance value is 2.5 ohm resistance, 2.5 ohm and 0.06 Henry, 0.06 Henry, and the capacitance value 6.8 microfarad, 6.8 microfarad. So these three elements connected in series and it is connected with the supply. The supply is 230 volt 50 hertz. Right. Now we have to find the impedance, current. That is, the first one is we should find the impedance. Second one is current. Third one is we have to find the phase angle between current and voltage, that is phi. And fourth one is power factor, that is cos phi. And fifth one is power consumed, that is real power, or we can say average power, or the another name is useful power, that is that power only consumed by these three load totally. Okay, so first we have to find the impedance. Now in this case we have resistance, inductance and capacitance. So we have to find the inductive reactance and inductive capacitive reactance. So for the XL inductive reactance, formula is 2 pi FL. So the 2 pi FL. Okay, now we have to use 2 into 50 to 5 value is 3.14, 2 5 L value is 0.06, 0.06. so answer is 18.84. so 18.84 ohm, that is XL. And XC value, XC formula is 1 by 2 pi FC. So 1 divided by 2 pi 50 into C value 6.8 into 10 to the power of minus 6. So we have to use the calculator. 1 divided by whole bracket 2 pi to phi value is 3.14 into 50 into 6.8 micro. So 6.8 into e power minus 6 close bracket. Now equal to symbol. You have to see the answer, 468.34. Okay, so the XC value is 468.34 ohm. Now compared to XC, the XL value is less, right? So to find the net reactance is X, which is greater number XC. So XC minus XL. So the net reactance is this value minus, then XL is 18.84. 18.84. So the answer is 449.5. 449.5 ohm. Then the impedance value is R. It is in real form. I am going to write real term. Then reactance, net reactance, right? But it is imaginary term. This is real term, and the symbol is minus. Okay, because XC value is dominant. Okay, XC capacitive reactance is dominant. That is why I am putting minus sign. So just this is the form for this problem, and so impedance is equal to 2.5 minus J. The net reactance is 449.5. Okay, now in our problem, the first thing we should find the impedance. Yeah, we found. And the second one is we should find the current. So to find the current value is equal to voltage, Ohm's law. I am applying Ohm's law, divided by voltage divided by impedance. So voltage is 230. Okay, it is given in our problem 230, but there is no angle. So if there is no angle, always you have to keep, if the RMS value is given, means you have to take it as a polar form, polar, and the given value is magnitude, but angle is not given, so you have to assume that is 0 degree. And in the denominator, impedance value 2.5 minus J 449.5, right? And I am going to find the current value in terms of polar. So already you know, see in the complex mode. Now the calculator in the complex mode only. So here I am going to put in the numerator open bracket, within that bracket 230 and angle is 0. So 230 I am going to type 230, and simply I have typed like that. And for the angle 0, so angle symbol is here, angle symbol is there. So shift after that this symbol, so angle symbol came, and now 0, type 0, then close that bracket, then that division symbol. After that in denominator open bracket 2.5 minus, right, minus, and we have to type that, say, J symbol after the number value. Okay, after the number you have to type that. So 449.5, first we have to type 449.5, then instead of J I am going to type I. Okay, here I only there, so this is the I came, then close that bracket. Now to see the answer, but it should be, now I want polar form, so for that polar form shift, okay, to see the answer continuously how to type shift, then polar, okay, shift to polar, so that symbol came here. Okay, to see the answer press equal to symbol. Now something is came, but so it seems this is the magnitude of the current, 0.5116, and to see the angle again shift equal to symbol, no need to again press polar, okay, equal to symbol. Now so you have to see nearby that number angle symbol is there, so it seems this is the angle of that current. So angle is 89.68, 89.68. Okay, now already we know our impedance is resistance and the net reactance is XC minus XL, because XC is dominant, so leading. Okay, the current is lead with the voltage, so we have to write the phase angle. Okay, in our question, third one is we should find the phase angle phi. So phi we found from this. The phi is 89.68 leading. Okay, leading. And after that, next we have to find power factor. Okay, so to find the power factor, cos, okay, cos and phi. So phi value is cos 89.68. Okay, so the answer is cos 89.68. The answer is 5.585 into 10 to the power of minus 3. Right. So 0.00558. Leading. Okay, leading. And then next we have to find the power. Okay, power equal to V into I into cos phi. So voltage magnitude, current magnitude and power factor. So voltage magnitude in that problem, the given data is 230 volt. Then current is, we have found the value. See in the problem, you have to see voltage is 230 magnitude. Okay, voltage is 230 magnitude, and then the current, obtained current is 0.5116. Okay, so we have to use those two value here. Okay, 230 into current is 0.5116, and then power factor value is 0.00558. So the answer is 230 into 0.5116 into 0.00558. Okay, so the power is 0.656 watt. Okay, that is the power. So for this problem, likewise we have to find the power factor, current, and then impedance value. Okay, so I hope you are all understood this, and thank you for watching this video.